Welcome back. This is the last problem that we're going to discuss on the concept of depression of freezing point. As I've said, the first video that I did working out the problem on sodium chloride is the foundational problem. The second problem we looked at is your ability to use the given information and structure out your calculation. This is just along the same veins that if you can solve a problem like this that just shows your level of thinking as far as gathering information from various parts of your brain and put them together and solve the problem. And so this is a problem. So you're dissolving 32 grams of sodium chloride in 40 grams of water. This is kind of a problem which is kind of like, oh, I know the molecular weight, but it's just being able to prove on the test or whatever, I might just give you an X instead of sodium chloride. Okay, but just to show you that we are able to get the weight back is an important thing, right? So you're dissolving this much solute in this much solvent, and the freezing point was lowered. Again, we already know the generic equation is delta TF equals KF times M times I. And delta TF is given to us as 5.23. KF is given to us as 1.86. And obviously, we don't know M, which we can find, okay? And I is 2 because sodium chloride is Na plus 1 and Cl 1 minus, so we get 2, okay? So if you solve all this, what do we get? 5.23 divided by 2 divided by 1.86. So molality is 1.405 M. What are we going to do with this information? Okay. Now again, as I said in the previous problem, if you're going to write it this way and leave it at that, you're probably going to be lost in your thinking process. So instead of it, write it as 1.40 moles of NaCl over 1 kilogram of solvent, right? Again, just like the previous case, we do know that we have dissolved 40 grams of water, which I'm not going to do the conversion because I just did it in the previous problem. So it's 0.4040 kilogram. So times 0.040, that gives us 0.056 moles of sodium chloride. Now, what do we need for molecular mass? Now, keep in mind, MM molecular mass is grams over mole. Now, we know the moles of sodium chloride. We know the grams of sodium chloride. All we got to do is put the two together, 32 grams. Again, starting here, this is all something you have done on exam 2, exam 3, practice exam 2, practice exam 3, and numerous quizzes and homeworks repeatedly. So this information right here is not new. So if you divide 32 divided by 0.056, it should have been 3.2, 0.056. Okay, correct this to 3.2 grams. I'm sorry, this should have been, let's say we're starting with 3.2 grams, because that would be 157 grams, which is not right. So it's 3.2 grams divided by 0.02 moles is roughly about 58 grams over mole. And we know that that's the molar mass of sodium chloride. Okay, so just make the correction. It's not 32 grams, it's 3.2 grams. Right? Now, up till here, all of you can do it. This is just basically problem 1. But starting here, it's all this information has been taught to you before. And so that's why I kept emphasizing when I was teaching 170 to you is all this information will be used again. So that's why we never learned it in a compartmentalized fashion. But when you don't do something, you still forget it no matter how well you learn something. So it's been about 15 days gap between when we finished that course and when we're starting this. So the break could technically make you lose touch of things. So that's why I'm trying to work it out to bring back some of your memory. And this is where we're going to stop the concept of freezing point, and then I'm going to show just one problem for the concept of osmotic pressure, because that's a pretty straightforward concept. All right, so stay tuned.